Imagine you're watching a mother animal with her newborns. She cleans them, feeds them, protects them, keeps predators away. Every instinct seems to point in one direction: keep the babies alive. Now imagine she suddenly turns around and eats one, not an enemy's baby, not another species, her own. It sounds like nature has completely lost the plot. But this behavior is real, and scientists call it filial cannibalism, when a parent consumes its own offspring. It's been documented in animals ranging from insects and fish to reptiles, birds and mammals. And the strangest part isn't that it happens. It's that, in some situations, eating your baby can actually increase the chances that your other babies survive. So why would an animal do something that seems completely insane? Is the parent starving? Is it sick? Does it not recognize its own offspring? Or is there a brutal calculation happening underneath all that instinct? Because once you see what nature is actually doing, bad parent starts looking like the wrong explanation. Let's start with the animal most likely to make you rethink everything you know about motherhood: the hamster. You probably picture a tiny fluffy creature stuffing food into its cheeks. Cute, harmless, basically a living potato with eyes. But after giving birth, a female Syrian hamster can sometimes kill and eat some of her own pups. And scientists have found something particularly interesting about when this happens. Energy matters a lot. Pregnancy has already drained the mother's reserves. Then lactation begins. Now she isn't just feeding herself, she's producing milk for an entire litter. And that costs enormous amounts of energy. In laboratory studies, researchers found that female hamsters with lower body fat or restricted food supplies were more likely to cannibalize offspring. In one 1989 study by J. E. Schneider and G. N. Wade, food restriction increased pup cannibalism, especially in lighter, leaner mothers. Think about what that means. The mother isn't necessarily choosing between eat babies and don't eat babies. She's facing a much uglier biological problem. Can I physically afford to raise this entire litter? Because sometimes the answer is no, and evolution doesn't care about what feels emotionally acceptable. It cares about whether enough offspring survive to reproduce. If a mother has 8 pups and enough energy to raise 6, keeping all 8 alive may mean losing all 8, but reducing the litter could leave the remaining 6 stronger, more milk per pup, more energy per survivor. A better chance of reaching adulthood. That's not kindness, it's resource allocation, and nature is extremely good at making horrible-looking decisions when resources are limited. If you're enjoying these strange stories about the hidden rules running the natural world, subscribe to the channel because the hamster is only the beginning, and the next example makes the behavior even harder to understand. Because what if the problem isn't the mother's hunger? What if the babies themselves are the problem? Imagine you're a fish guarding a nest. Hundreds of eggs are sitting there. You're protecting them from predators. You're constantly moving water over them. You're spending energy. You're not eating properly because leaving the nest could expose the eggs. And then you notice something. A few eggs have gone bad. They're covered in fungus. They're dead. Now you have a choice. Leave them there or eat them. And in some fish, eating your own eggs can actually be part of parental care. Researchers studying the common goby, for example, found that caring males consumed significantly more eggs that had previously been exposed to water mold than healthy eggs. Removing those infected eggs can reduce the risk of the infection spreading through the nest. So the parent is technically eating its own offspring. But the behavior is doing something else at the same time. It's cleaning the nursery. That's the first big twist. Sometimes the baby isn't being eaten because the parent has given up. The baby is being removed because keeping it alive, or even keeping its body in the nest, can endanger everyone else. And that leads to an uncomfortable question. What if nature doesn't think of every baby as equally valuable? We tend to think of offspring as a single category. Baby, therefore, protect. But evolution doesn't work with categories like that. It works with probabilities. This egg has a high chance of surviving. That one is infected. This pup is healthy. That one is unlikely to make it. This nest has enough food. That nest doesn't. The parent is constantly operating under uncertainty. And when the resources aren't enough for everyone, something has to give. In some species, the parent simply abandons the weakest offspring. In others, it may consume them. The result looks horrifying. The underlying calculation is survival. And fish take this to an even stranger level. In some species, the parent doesn't just occasionally eat one of its offspring. It can consume part of the clutch while continuing to guard the rest. This has been studied particularly well in fish with paternal care. Male three-spined sticklebacks, for example, build nests and guard eggs after females lay them. Researchers have found that these males sometimes eat their own offspring, and that factors including the proportion of unrelated eggs in the nest can influence cannibalism. And now the story gets weird. Because sometimes the father may not even know exactly which eggs are his. Imagine spending days guarding a nest. Then another male sneaks in, fertilizes some eggs, or eggs from another nest end up in yours. Now you've got hundreds of tiny embryos mixed together, and suddenly the father has a problem. Which ones belong to me? Some fish appear capable of responding to cues associated with their own offspring, but the system isn't perfect. Genetic studies have directly confirmed that some nest-guarding fish fathers really do consume their own genetic offspring, even when unrelated embryos are also present. That tells you something important. Filial cannibalism isn't always about recognizing a bad baby. Sometimes it's simply the consequence of a parent making decisions inside an imperfect biological system. And here's where you might be tempted to say, fine, fish are weird, but mammals do this too. And mammals are much harder to dismiss because their babies look so much more familiar to us. A mother hamster can smell her pups, nurse them, build a nest for them, carry them, and still eat some of them. Why? Because motherhood isn't a single switch that says protect everything. It's a collection of competing biological systems: hunger, hormones, stress, energy reserves, milk production, nest security, predator risk, litter size, and reproductive opportunity. All of them are interacting, and sometimes they point in different directions. That is why the environment matters so much. In a 1991 study of Syrian hamsters, researchers found that maternal litter reduction through cannibalism was influenced by food availability, body fat, and even ambient temperature. The number of pups eaten changed with the mother's available energy reserves. Think about that for a second. A behavior that looks like pure aggression can actually be connected to something as boring as calories. Nature doesn't have a moral scoreboard, it has an energy budget. And babies are expensive. But there is another reason parents may consume offspring. And this one sounds almost crueler. Sometimes, the parent may be cutting its losses. Imagine a litter born at exactly the wrong time. Winter is coming, food is disappearing, the mother has limited energy. She has more babies than she can realistically support. If she tries to raise all of them, the entire litter may fail. Reducing the number can redirect resources toward the survivors. Researchers studying filial cannibalism have described this as a trade-off between current offspring and the parent's ability to maintain care for the remaining brood or reproduce again in the future. And that's one of the hardest ideas to accept about evolution. Sometimes survival doesn't mean saving everyone. Sometimes it means saving enough. That principle appears everywhere in nature. Plants produce thousands of seeds knowing most will die. Fish can release thousands of eggs knowing predators will eat most of them. Birds may produce more chicks than they can always successfully raise. And some mammals give birth to litters larger than the number they can reliably support under bad conditions. Evolution often works with enormous numbers and terrible odds. Humans are unusual because we emotionally focus on the individual. Nature often operates on the reproductive outcome, and that difference makes animal behavior look much more horrifying than it is from the animal's perspective. But there is still one mystery. Why would evolution ever allow a parent to develop an instinct that could literally destroy its own offspring? Shouldn't natural selection eliminate that? Actually, not necessarily. If eating one offspring increases the survival of 5 others, the behavior can potentially be favored. If consuming an infected egg protects hundreds of healthy eggs, it can be favored. If a starving parent gets enough energy to continue guarding the nest, it can be favored. And if a parent is investing in reproduction now while preserving its ability to reproduce later, the calculation becomes even more complicated. This is why scientists don't treat filial cannibalism as one single behavior with one single explanation. Different species can arrive at similar behavior for different reasons. Food availability, brood size, parent condition, disease, predator pressure, paternity, season, temperature, even the age and condition of the offspring can matter. So the phrase "animals eat their babies" hides an enormous amount of biology. It's like saying, humans eat food, technically true, but it tells you almost nothing about why. And there is one particularly disturbing example that shows just how flexible this system can become. Syrian hamsters don't simply cannibalize randomly. Research has found that under some conditions, mothers can show differences in which offspring are consumed, including patterns related to sex and environmental conditions. One study reported increased cannibalism with larger litters and evidence of sex ratio adjustment under certain seasonal conditions. That doesn't mean the mother is consciously choosing, "I prefer daughters." There is no tiny hamster accountant keeping demographic records. It's an evolved response to environmental signals. The body is responding to conditions that historically predicted whether particular offspring were likely to survive. And that is the deeper pattern. The parent isn't necessarily optimizing the baby, it's optimizing reproduction under difficult conditions. Those are not always the same thing. Now imagine you are a male fish guarding hundreds of eggs. You're exhausted, you've barely eaten, a predator is nearby, some eggs are infected, others may not even be yours, and every minute you spend guarding the nest costs energy. Suddenly, eating a few eggs doesn't look like a random act of violence. It becomes one possible response to an impossible situation. Eat some, gain energy, remove unhealthy eggs, continue guarding the rest. And if the remaining offspring survive, the behavior may have increased the parent's reproductive success. That is why scientists use the term filial cannibalism rather than simply calling it bad parenting. Because evolution isn't asking, "Was that a good parent?" It's asking, "Did this behavior leave more surviving descendants?" And those are very different questions. There is another fascinating consequence of this. Filial cannibalism tends to appear alongside parental care in many species. That sounds contradictory, but it's actually logical. If a parent doesn't care about the offspring at all, eating them isn't really a conflict. The paradox exists precisely because the parent is investing heavily in them. It's guarding them, feeding them, cleaning them, protecting them, and under certain circumstances, removing some. Research on parental care in filial cannibalism has found this combination across a wide range of animals, particularly fish and arthropods, but also mammals, birds and reptiles. So the behavior isn't the opposite of parental care. Sometimes, it's one of the decisions made inside parental care. That's the part that makes nature so uncomfortable. Because we want the world to have clean categories. Mother means protector, baby means innocent, parent means sacrifice. But evolution doesn't promise clean categories. It produces compromises, and compromises can look monstrous. A starving hamster doesn't understand fitness. A fish doesn't understand resource allocation. A parent removing infected eggs doesn't understand microbiology. They simply respond to signals that, over enormous stretches of evolutionary time, tended to produce more surviving offspring. And those responses became instincts. That's why an animal can behave as though it loves its babies and still consume one. The two behaviors aren't necessarily contradictory. They're both parts of the same biological problem. How do I get the next generation through a world that may not have enough for everyone? And that problem is much older than mammals. Much older than humans. Older than anything resembling civilization. Life has been making this calculation for hundreds of millions of years. Some offspring will survive, some won't. Parents invest, parents abandon, parents protect, parents sometimes eat. And the horrifying part is that all of those behaviors can exist inside the same species. The difference is the environment. Change the food, change the temperature, change the number of offspring, change the disease risk, change the predator pressure, change the parent's condition, and suddenly the behavior can change too. That means the animal isn't simply a cannibal, it's responding to a situation. And that may be the most important thing to understand, because when you see a mother animal eating one of her babies, your first reaction is probably, what is wrong with her? But biology asks a different question. What changed? Was food scarce? Was the litter too large? Was an egg infected? Was the parent exhausted? Was the nest under threat? Was reproduction happening at the wrong time? Was the offspring unlikely to survive? The answer can turn a horrifying scene into something much more complicated. Not beautiful, not pleasant, but understandable. And maybe that's what makes nature so fascinating. It doesn't operate according to the stories we tell ourselves. It operates through trade-offs. A parent can sacrifice one offspring to protect the rest. A fish can eat an infected egg to save a nest. A starving mammal can consume part of a litter to preserve enough energy to raise the survivors. And sometimes, the behavior that looks most cruel from the outside is connected to the same biological machinery that makes parental care possible in the first place. So the next time you see an animal protecting its babies, remember that you're seeing only one side of the equation. Because somewhere in nature, another parent is facing a terrible choice. Protect everyone when there isn't enough, or sacrifice something to save what can still survive. And evolution doesn't care which option feels kinder. It cares which option works. If you enjoyed this story, hit like, subscribe to the channel, and tell me in the comments which animal behavior should we investigate next. Because nature is full of behaviors that look completely insane until you discover the problem they were built to solve. And sometimes the most disturbing lesson is also the simplest. In nature, survival doesn't always mean saving every life. Sometimes it means knowing what you can afford to lose.